Hello everyone, I hope you're doing well. Today I'm going to explain the Unit 3, Part 2, TGA Congruence and Constructions. So let's take a look at the first question. It tells you that provide reasons for the statement. The information that is already given is that angle 1 and angle 3 are vertical angles. So let's take a look. Angle 1, angle 3. They are vertical angles because they are opposite to each other. They're going to be congruent. That means that they're going to have the same measurement. And also angle 2 and 4 are also vertical. So you're going to prove that angle 1 is congruent, same measurement as angle 3. Remember, this symbol means congruent. So for this part, you're going to be using the list of definitions, postulates, and theorems I shared with you guys at the start of the semester. And like I explained, also use this list for Unit 2 TGA. So you're going to go to Modules, and then you're going to go to Download, please, List of Geometric Definition, Theorems, Postulates, and Properties. And then you're going to download it. You're going to click on it. It's going to appear this, and you're going to download the PDF. Okay, and then it's going to appear this part. Like I explained before, here the first part are the types of angles. Remember, complementary angles, they are angles that add to 90 degrees. Okay, they form both of them should add to 90. Supplementary, this is the explanation of it. You're going to have two angles equal to 180. So when you have this as a statement, your reason is going to be a definition. Okay, acute angle, here you have an explanation of how acute angle less than 90 and greater than 0. Right angle, it's a measurement of 90 degrees. Obtuse, less than 180 and greater than 90. A straight angle, remember, is a straight line that measures exactly 180 degrees. Then we have the midpoint. Okay, here you have it. AB is congruent to BC because remember, the midpoint is the midpoint of that segment. Angle bisectors, it divides the angle in half, and then those two angles that are going to be created are going to be congruent. So if they give you this explanation that is on the middle of the column, then you're going to be talking about definitions. Okay, then I also explained this before. We have the perpendicular bisector, right, divides that segment in two. Where perpendicular lines are lines that are not going to intersect, and they're going to form a 90-degree angle. Parallel lines, they never intersect. Perpendicular lines, like I said, they're going to intersect and form a 90-degree. Right triangle is a triangle that has a 90-degree angle. Linear pair, two angles that form a line, right, and they form a 90-degree angle. Then vertical angles, what we are reviewing right now, is two angles formed by intersecting lines and facing in opposite directions. So this is a definition of vertical angles. And then we have similar triangles too, where here you have them. The angles are going to have the same measurements. Okay, here you have an angle A is congruent to angle X, angle B is congruent to angle Y, angle C is congruent to angle C, and their sides are going to be proportional. Okay, then we're going to go a little bit, just zoom in a little. Then the angles, which we also review in Unit 2, angle congruent postulate, two angles are going to be congruent, they're going to have the same measurement. Angle addition postulate, when two angles are going to be added together, they're adjacent to each other. Linear pair postulates, two angles that are adjacent and added together are going to be equal to 180 degrees, forming a straight line. Then we have the vertical angle theorem, which we are also reviewing that. Angle 1, when they tell you angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4, then we're talking about vertical angle theorem. Okay, alternating interior angle theorem is when you're going to have, remember, the transversal, right, that passes through the two parallel lines, and angle 1 and 2 are alternating interior because alternating means that one angle is on the left side of transversal, the other one is on the right side. and they're going to be interior inside the parallel lines, and they're going to be congruent. So this is just a review. The alternate exterior, remember angle 1 and 8. Here you have an angle 2 and 8. Alternate, that means that it's one angle is on one side of the transversal, the other one is on the other side. In exterior, they're outside the parallel lines. Then we have the same side interior angles. For example, angle 3 plus angle 5, they're equal to 180. Here you have in 3 and 5. Both of them are on the same side of the transversal, in this case on the left, and they're inside the parallel lines. Then we have the corresponding angles. For example, angle 1 and 5, if you guys see, they're on the same side of the transversal, but one is on the outside of the parallel lines and the other one is in the inside. Okay, it's same thing for angle 2 and 6, 3 and 7, and 4 and 8. Then we're also going to have the properties. Okay, the properties of equality. Addition, when, for example, to isolate x, you add plus 5 on both sides to get 7. Subtraction, property of equality, you subtract the number on both sides. So to isolate x, you subtract 5 on both sides, so you get -3. Multiplication, property of equality, you multiply the same number to both sides. So for example, you isolate x, the 3 is divided, so you move it multiplicating the 4. 4 times 3, 12. Division property, you divide the same number on both sides. So you isolate x, so you divide both sides by 3. 15 divided by 3 is 5. Substitution property, when they're gonna give you a value. For example, y equals x plus 5. So you have here the equation x plus y equals 10, so you substitute on y x plus 5. So whenever you substitute, you're going to be using that equality. And then we also have the distributive property. You just remember when you have a parenthesis, that means that the -3 is going to multiply that's x, the -3 is going to multiply the -4. Combining like terms, you, for example, 3x and -5x, they have the same variable, right? And the same exponent. So 3 minus 5 is -2x. And then -4 plus 2y, they have the same variable and exponent. So -4 plus 2 is negative. It would be -2. And then the numbers constants, 1 plus 6, 7. Then you have the reflexive property. Value is equal to itself. Symmetric, if AB equals B, then B equals A, you just switch. Transitive property of equality, if A equals B and B equals C, then A equals C. And then we have here the triangles, okay? So you have the side, 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 congruent postulate. That means that you're gonna have two triangles, okay? And the sides are going to be congruent. So you have to take a look at the tick marks. For example, this side has one tick mark, so it's going to be congruent to this side. This one has two tick marks, so it's going to be congruent to this other side. This side has 3 tick marks, so it's congruent to this one. So it means that all the sides have the same measurement. Then you have the side angle side, which means you're going to have a side that is congruent to tick marks, a side. Then you're going to have in between an angle that is congruent, and then a 3 tick mark means that this side is congruent. So side, an angle, and a side, whereas the angle is in between. Then you're going to have the angle side angle. So you're going to have angle, which is this one, the one that has one curve. That means it's congruent to this one. Then a side that is congruent, and then an angle. So the side is going to be in between now. And then you have the AAS, which is 2 consecutive angles. This one, angle, angle, and a side. Angle, angle, and a side. And then we are going to have other postulates that we have here. Hypotenuse leg postulate. So if the hypotenuse and one of the legs are equal in measure to the hypotenuse and leg of another right triangle, then the two triangles are congruent. Okay, so you're going to have a right triangle that forms a 90-degree angle. Okay, then we're going to have a side, which are the legs. This is the leg. Okay, and then this that is across the 90-degree angle, across the little square, is a hypotenuse, which has 3 tick marks. Then the angle, if two angles of one triangle are equal in measurement to two angles of the other triangle. And then we have the side, which is the same thing. And then corresponding parts of congruent triangles are congruent. It's this one, where all the sides, you have 1 tick mark, 1 tick mark, 2 tick marks is congruent to this side, 3 tick marks to this other side, and the angles are also congruent. Okay, so this is the list of what you're going to be using. So for the second part, for the reason, you're going to be using that list, okay? In this case, angle 1 and 3 are vertical angles. That information is already given for you, okay? Here you have it. So that's why you write it given. Then, angle 1 and 2 form a linear pair. 2 and 3 form a linear pair. So that's the definition of linear pair. And on your own, based on that list, you're going to tell me angle 1 and 2 are supplementary. What would it be? Then, measurements of angle 1 plus measurement of angle 2 is equal to 180. Okay? Remember, which ones are the ones that are equal to 180? Well, the supplementary, right? Then, measurement of angle 1 plus the measurement of angle 2 equals to measurement of angle 2 plus the measurement of angle 3. So what's happening there? Then, what did they do to get measurement of angle 1 equals to measurement of angle 3? Look at this. I'm going to give you a hint there. You have here, it's repeated, right? So what happens from this step to this step? What if I subtract? They cancel out. So I'm going to give you help you out there. It's the subtraction property of equality. And then from this step to this step, these two angles are equal. So how is that called? Okay. Then that's the first part. You're going to use that list like in Unit 2. Then let's take a look at problem number 2. It says in the figure, point B, so here you have it, point B, is the middle point of segment AC. Okay? So you see point B is in the middle of AC. Use the figure to answer the question. So Jeremy says that triangle ABD, so let's color it, ABD, this triangle, okay, is congruent to CBD. So CBD, they're congruent, okay? They're going to have, the sides are going to be the same, the angles also. By the side angle side, that means that the sides are going to be congruent, the angle and the side, okay? Do you agree or disagree? Explain. So, for this, you can look at the order of the letters, okay? So, A is gonna, let me just color them. We're gonna use blue, okay? A is congruent to, angle A is congruent to angle C, right? So I'm gonna do one curve, right? Angle B, get what happens here to a green. Angle B is congruent to angle B. It is, right? Because this is the same angle. It's a 90-degree angle. I'm not going to put a curve. I'm just going to put a little square because they're congruent and they form a line which is 180 degrees. And then let's take a look at the next one. Put it in red. Angle D is congruent to angle D. Let's take a look. And they are, right? I'm going to put 2. Okay. Now, let's take a look. Those are the angles. Let's take a look at the segments. Okay. So for that, I'm going to be using tick marks. Okay. So let's take a look. AB. Let's take a look at the order. AB. I'm going to put 1 tick mark. is congruent to CB. One tick mark. That's true, right? Then BD, let's take a look at the second and third letter. BD, I'm going to put 2 tick marks. It's congruent to BD. Now, is that true? So you have BD. Oh, let me go back to it. BD, this is BD. 2 tick marks. There you go. It's congruent to BD. It is, right? Because they're sharing that side. And the last one, AD, just look at the first one and the last one. This 2 and this 2. So you do the first 2, second and third, and then the first and last. These ones are congruent. Okay? So we already checked out that the order is true, right? The angles are congruent, the sides are congruent. So, would it be a side angle side? You're going to tell me if you agree or disagree and why. I already helped you out identifying which sides and angles are congruent. So on your own, you're going to explain to me. Remember, S stands for a side that is congruent, an angle in between, and then a side. Okay? Now, letter B. Suppose it is also known that AD, segment AD, so let me color it in blue. AD is congruent to CD, which it is, right? Which postulate or theorem can be used to prove that triangle ABD is congruent to CBD? Okay, so you already know that they're congruent. So which postulate would it be? So you're going to go to the postulate area, postulate theorem, and you're going to tell me what you're going to be using to prove that. Okay? And then we have the last part. Use rigid motion to explain whether the triangle in the figure are congruent. Be sure to describe specific rigid motions in the explanation. Remember, rigid motions, which are they? They're going to be, there are just 3 of them. Rigid motions means that they're going to have the same shape, okay, and the same side. So we have reflection, right? Translation, those are one, reflection, translation, and rotation. So just by looking at it, what's happening? So you're going to explain to me on your own what rigid transformation. I cannot have dilations because they're not changing the size, okay? And here, what I'm going to recommend you is to give me the coordinates of each point, okay? Analyze which ones are congruent. For example, angle S or point S, we can do it angle S, point S, is congruent to which one? Well, if I look at it, analyze it, it's going to be congruent to P, right? Then angle M, I'm going to put 2, it's to D. And angle W is to J. So I'm going to put 3. Okay, so what you guys can do is give me the coordinates. For example, point S, which are the coordinates? Well, on X, 1, 2, 3, -3, and you go up 1, so it's positive, right? And then what do I have on D? Well, I have 2 on the left, 1, 2, and up. 1, 2, 3, 4 positive, okay? So what's happening there? Okay, now you can also, just by visualizing, you can conclude, or you can use here the rules transformations that I share with you, and we reviewed this on Unit 1. So here you have them, and you want to verify it through the coordinates, and then remember, reflection over the x-axis, so it's when you reflect it this way, right? What happens? The y is the one that's going to change, either positive or negative. Over the y-axis, that means that you're going to have the same figure this way. The only thing that changes is the x, either positive or negative. If it's positive to negative, negative to positive. Reflection over the y equal x is just a diagonal. What happens here? You only switch. You don't change signs. 90-degree clockwise rotation. Okay, look what happens. You switch and you change the sign of the x. Okay, positive, negative, negative, positive. 90 counterclock. Clockwise, remember it's this way, right? Like the clock. Counter, it's going to be this way. What happens here? You switch, but you change the sign of the y, right? 180 rotation clockwise and counterclockwise, you're going to have the same one. You're going to switch. I'm sorry, you're just going to change the sign. It's positive to negative, negative to positive. And it's usually, if it's on the first quadrant, the figure is going to be on this. If it's on the second, the other figure is going to be on the other fourth quadrant. Okay, in translation, you just move, right? You don't switch or you don't change the sign. Well, you're going to change the sign if you're going to add or subtract, okay, on x or y. Either x plus 1, x minus 3. So you're going to move either up, down, left, or right. Okay, so these are the algebraic rules which we already reviewed. I'm just adding them. So if you want to use them, so it can help you here establish what is happening. Is it a reflection? Is it a translation, a rotation? What is happening here? Okay, and remember you can also use GeoGebra if it helps you out. So if you have any questions, please make sure you reach out. Make sure you use your notes and the recordings that I did before on class that are on Canvas. And everybody have a wonderful day. Take care.